to True Projects. In this video, we are going to explain about the project that is machine learning in money laundering detection over blockchain technology. So before getting into the execution, first let us understand what is this project about. Cryptocurrencies, they have become more than just digital money. They are now tools that can be misused by criminals. People use them for activities like money laundering, fraud, and trading illegal goods on the dark web. The technology behind cryptocurrencies, called blockchain, is designed to be secure and transparent, but it is decentralized and anonymous nature makes it possible for criminals to hide everything, that is hide where money comes from and where it goes. Sometimes cryptocurrencies like Monero, Zero Cash offer even stronger privacy features than Bitcoin. These features makes it much harder for authorities to trace transactions or identity the people involved. This combination of security, anonymity, and privacy makes cryptocurrencies appealing not just for legitimate use, but also for hiding illegal activities. Even though blockchain allows anyone to see all transactions, the people involved remain anonymous because wallet addresses don't reveal real identities. This anonymity makes it very hard for authorities to figure out who is behind illegal transactions. Criminals take advantage of this by moving money across many different wallets or exchanges, which hides the trail and makes suspicious activity hard to spot. So, traditional methods for detecting money laundering often struggle with these complex patterns, and there is currently no system that can reliably trace these anonymous users back to the people conducting the crimes. This makes tracking and stopping illegal cryptocurrency transactions a real challenge for law enforcement. Here, the main challenge with cryptocurrencies is that their designs make illegal activity hard to detect. Transactions are anonymous, decentralized, and often complicated, so it is difficult to know who is sending or receiving the funds. So, this creates a serious problem for financial regulators and law enforcement agencies tracking and stopping crimes like money laundering and other cyber crimes in the digital currency world, which becomes extremely challenging because of these features. So the system we have built is to detect illegal cryptocurrency transactions by using machine learning, combined with method called VTAC. VTAC is value-driven transactional tracking analytics for crypto compliance, which helps to track the transaction patterns. So its main goal here is to spot suspicious activity and figure out details about the people involved in these transactions. So first, data is prepared by cleaning it up, filling in missing information, and converting everything into a format that computers can understand. Then the data is normalized so that the models can understand and train them. So data will be normalized to equal scale. Then comes model training. So at this stage, models that are machine learning models like Random Forest, XGBoost, and AdaBoost are trained on historical transaction data to learn what typical and suspicious activity looks like. Next, the system, it can identify the hash addresses linked to the transactions, helping investigators see whether a transaction might be illegal and giving clues about who is behind it. Then VTAC. So this VTAC examines the transactions for unusual patterns such as high number of transfers in the short time to flag potential illegal behavior. Finally, the system is evaluated using all the metrics that are accuracy, precision, recall, and FN score, and also confusion matrix. Moving on, as an extension, more advanced machine learning models are applied to improve the accuracy for detecting illegal cryptocurrency transactions. So here, a hybrid model has been incorporated which combines XGBoost and random forest, which helps the system to better recognize suspicious patterns and unusual activity. Then comes incorporation of LightGBM and CADBoost. So LightGBM and CADBoost are incorporated to compare their performance. Among all the tested models, LightGBM achieved the highest accuracy, showing that advanced and hybrid approaches can significantly enhance the detection of illegal transactions. And these are the algorithms used in this project to predict whether it is illegal or legal activity. And here we have requirements. So to implement this project, basically we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So these are the source code files of the project. And here is the dataset that is used to train. So here we have different features. So let's open this elliptic TX features. It's loading, just wait for a while. Until then, let's understand the other files. And here we have test data that we will be using in the front end for prediction. And here we have model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. Here we have static folder, which contains CSS, JavaScript, and Bootstrap files, which are important for the project's visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have database file, which is used to store the user information. And this is the Windows batch file. So instead of executing project through command line interface, we have created this Windows batch file. Here the dataset has been opened. So this is the dataset that we have used it for training. Let's close this. Close it and get back. Now double click on this run file. Here you can see app.py file has been compiled. It will execute Python script and perform a runtime check for any syntax errors or logical issues in the code. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So just wait for a while, it is being compiled. So this is the address where application has been hosted. So copy this link provided by the Flask framework. So copy it and paste it into any web browser. I prefer Google Chrome, so I will paste it in that. So paste the link here. Now click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So first we need to get registered. So click on register here. So let's create an account. So give username, password, contact number. So let's give a random contact number, an email ID, and the address. Now click on create account. So sign up process completed and we can log in to perform illicit blockchain transaction. That is illegal blockchain transaction detection. So let's click on login here and provide username and the password. Now click on login. We have logged in successfully and redirected to this page of this project, that is the admin dashboard. And here first we need to load and pre-process the dataset on the dashboard. So click on load and pre-process elliptic dataset. So click on it. Here you can see dataset is loaded successfully, and here total we have 46,564 records, two class labels, that is legal and illegal, and we have assigned 37,251 for training and 9,313 for testing. And here we have two class labels, that is illegal and legal. And here we have 80% of the data set is split for training and 20% is assigned for testing. And here we have total 10 features. So these are the first 10 records of the data set. Here you can see TXID, time, local 0, local 1, local 2. So these are different features of the data set. So here we have total different features. And here we have top 10 records of this data set. So here we have top 10 records. And now let's click on train existing and VDAC model. So click on that. So now the models will be trained on the given data set, that is a pre-processed data set. So here we have the performance, that is the algorithm performance comparison. So these are all the different models that we have trained on the elliptic data set to predict whether the transaction is legal or illegal. So here we have used random forest, XGBoost, AdaBoost, that are the existing models, and the proposed model, that is VTAC random forest, VTAC XGBoost, VTAC AdaBoost, and these are two extension models. So here we have their accuracy scores, precision, recall, and inference scores. So these are the evaluation metrics that are used to evaluate the model. And here if you observe, we have 99.742, that is 99.7 742 for the light GBM, which is achieving the highest accuracy score. And also we have precision, the highest score. Recall is also having 98% and 99% FN score. So light GBM model is performing well. And here you can see best performing model is the extension to light GBM, which achieved highest accuracy of 99.72. And here we have confusion matrix, which shows the, I mean, here on x-axis we have predicted label and on y-axis we have actual label. And here this diagonal shows the accurate predictions and this diagonal shows the misclassifications. And now here we have AI algorithms comparison graph. So here on x-axis we have all the models that we have trained, and on y-axis we have all the measures, that is accuracy, precision, recall, and FN score. Here each color represents one type of accuracy. Let's zoom it. So here if you observe, on x-axis we have all the models and on y-axis we have each algorithm score. Here blue color line represents the accuracy, orange represents FN score, red represents recall, and green represents precision. Now let's predict the electric transaction. So click on that. So click on choose file. So let's upload test data and now click on open. Click on predict transactions. So here we have predictions. So first we have transaction ID of each transactions, that is each blockchain transactions. For each blockchain transaction, we will be having hash code, right? So that is the hash code. And this is the value of that. And here you can see illegal activity has been detected. So this blockchain transaction is illegal transaction. Accordingly, second blockchain transaction with this hash code is the legal transaction. So the third one is also legal and the fourth one is illegal. You can observe illegal has been predicted. And here you can see legal, and this transaction with this transaction ID and with this hash code is illegal. Accordingly, we have here legal values and illegals are predicted. If you observe total, there are 14 transactions. In that, 7 are illegal transactions, that are illegal blockchain transactions that have been done, and 7 legal transactions. So here you can observe there is 70, that is 50% of the illegal rate that has been done. That is illegal blockchain transactions that is done. So in this way, you can check with the other values also. Now click on logout, that is with the other blockchain records. So this project, it helps make the world of digital money safer. It shows how we can track suspicious activity and stop illegal transactions, giving authorities the tools they need to prevent crime and protect people in the digital world. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.